word banks for each one of these proofs. So we have 6 proofs we're going to do. This side has all the word banks. So if you flip this page, you have like 1 through 6. This is like your word banks. You will never be given a proof in geometry without options. Either on the test, it's going to have a little drop-down box to choose from, or you're going to have a word bank to choose from. If they give you a word bank, because it's our first day, I like left it to where like you have just enough to fill in each blank. Sometimes they're going to give you extras because they like to mess with you so that we can't use process of elimination, just so you're aware. So let's go to the front. So segment proofs, this is what we talked about yesterday, is addition property, subtraction property, multiplication property, division property, distributive property, substitution. And then we talked about geometry proofs, reflexive, symmetric, and transitive. We're going to review those 3 because those 3 are the most important ones. Those are the new ones for geometry. So reflexive property. Does anybody remember reflexive property from yesterday?
Like the same thing.
It's the same thing. It's stupid because it's the RE. Let's put repeat above it. It literally repeats itself. It's silly. But for any segment AB, I could say AB is congruent because it says reflexive property of congruence. So now it's just a congruent symbol. Yes. Yes. Come here. So I could say AB equals or is congruent to AB. It's literally the identical. It's pointless. It's silly. And you're like, what was the point of that? Literally nothing. Literally just to confuse you. So if I look at 1 through 14 off to the side, can anybody point out 1 through 14, which one represents reflexive? Number 3 is the only reflexive because it's number 3 is identical to itself. So that's going to be reflexive property. It's like you can put POC, that's fine. I'm just gonna put prop, reflexive prop. For the next one, it says symmetric property. What did we learn about this one yesterday?
It's like on one side it'll be like this.
Is it what?
It's flipped. So it's the same, but it's flipped. And that's why people get symmetric and reflexive switched. Symmetric is the same. So if I say AB is congruent to, let's say, BC. I don't know why I said BC. Whatever, it doesn't matter. Then BC is congruent to AB. So it's literally identical, but it's flipped. No, that's not 5.
So 1 and 11.
1 and 11. Good job.
Oh,
Wait,
So hold on. So 1 says PQ equals PQ, then PQ is congruent to PQ. Oh, that's not 1. I'm sorry. Yeah, it's 5. I was thinking, my bad. There's only one symmetric property. Next one's transitive property. Transitive property is the weirdo that we talked about yesterday. It's like, if this is congruent to this and this is congruent to this, then I can cross out what they share and put the first and the last equal to each other. So we're going to say for this one, let's say AB is congruent to CD. And I know CD is congruent to D. They both share that CD aspect, so I can technically cross out what they share, and I can say AB is congruent to DE. So it's removing the middleman. There's 2, not 9. One of them is 7. 7 says if FG is congruent to HI is congruent to JK. I can cross out HI and say FG is equal to JK. So 7 is transitive. And then 14 is also crap. I'm gonna zoom out just a little bit. 14 is also transitive because RS is equal to ST. ST is congruent to 2U. So they cross out ST and then set them equal to each other. Transitive.
But 8 not here.
No. I just not use the same color twice. Okay, the next thing is definition of congruence. we know about congruence because we've used it since chapter 1. So congruence means that they're equal. If this is equal, then that means it's congruent. If it's congruent, it's equal. We're all equal, we're all congruent. So definition of congruence says segments are congruent if and only if, which is actually a biconditional statement on that little poster right there from our sentences, they have the same measure. So what we're going to say is if AB is congruent to CD, if I know they're congruent, then I know that they're equal. So I could say AB is equal to CD. And then you can flip it too. If you know something's equal, then something's congruent because what you know can go back and forth. So if I know it's equal, then I know it's also congruent. Oh gosh. Hold on. I'm like messing up really bad right now. I made them all. This is why I hate words. How bad. Okay. So if it's congruent, it's equal. If it's equal, it's congruent. Same thing. Okay. So which number actually matches that? 11 matches it. 11 says if it's congruent, then it's equal. Hold on. And then the other one is what? Number 1. Because if it's equal, it's congruent. The next thing is midpoints, which we did in chapter 1. All of this is from chapter 1. Definition of midpoint, if you have common sense, midpoint is the middle points in the middle. Okay, so it says the midpoint of a segment divides a segment into 2 congruent parts, which are equal lengths. So if M is the midpoint of AB, I can technically say that AM is equal to MB. Because it's the midpoint. It's in the middle. There are 2 definitions of midpoints. 6 is definition of midpoint. Hold on. So 6 is one of them, and then 10. Yeah, that's fine. Yeah, if you want to shorthand it. Yep. And then the last new thing for today, which is technically also old, is segment addition postulate. We did segment addition postulate chapter 1. We also did segment addition or angle addition postulate. But angle addition postulate, you're taking one piece, you're adding another piece, and it equals the whole thing. Just like from chapter 1. Chapter 1 is little piece plus little piece equals whole. So what we're going to write for this one, let me pick the color. I haven't used multiple uses purple color. Oh, I haven't used red. So let's use AB plus BC. And little piece plus little piece equals the whole thing. The whole thing is A to C. So there are how many? There's one segment addition postulate. It is 2. And no, but we will shorten it. Let's just put seg addition postulate. So we can shorten it.
Say that.
Segment addition postulate. So if K is between J and L, then JK plus KL equals JL. So piece plus piece equals whole thing. The ones that are blank, that are still blank, are a review from yesterday. We have not talked about distributive property. We have not talked about substitution. We have not talked about addition, subtraction, multiplication, and division. So those are our last options. So let's go through number 4. We're just going to fill these in from what we know from yesterday. 4 says if RS equals TU, so we're starting with this, then RS plus XY equals TU plus XY. Addition, because it's adding to both sides. So that's addition. Property of equality, which is POE, or just put addition property. 8 says AB plus CD equals EF plus CD. Notice it starts with adding, and then it says AB equals EF. So what do they do to get rid of it? They subtracted. So you would have to subtract CD to both sides to get rid of CD. So subtraction. Number 9 is the hardest from thinking from yesterday. It says if PQ plus RS equals TB and RS equals WX, then PQ plus WX equals TD. Notice that the only two things that changed is this. So what is that property called from yesterday? Substitution. So it's replacing it, substitution. And then the other last two, 12 says CD plus DE equals CE, then CD equals CE minus DE. Is that one? Somebody was about to say it. Subtraction. I don't know why I wrote it all out. Whatever. And then 13 says 2xy equals xe, then xy equals 1/2 division. Okay, so now we're gonna go to the next page. The next page is all the word banks. So you're gonna have possible word banks. These are your options. These are your options. So I would like lay your paper like kind of flat, hopefully, to where you lay it flat, you can kind of like see maybe like both things, maybe. Like I would like overlap it or something. That way you can see like or you can unstable it and restable it later. Yeah, that's fine. Unstable it, restable later, that's fine. But I just like squished mine so that way it lays like flat. So problem number 1, word bank matches with problem number 1 problem. Okay. I also cut them out so I can show you as we go the word bank, but on your word bank, if you want to cross out each one as we go, that is also fine. So for number 1, these are my options. It says we have addition property, given, transitive property, definition of midpoint, segment, addition postulate, and simplify. So for numero uno, given, E is the midpoint of DF. Prove 2 of these equal to the whole thing. So E is the midpoint of DF. Given, the first step is always given every single time. On your word bank, I would cross off given. I'm not crossing it off because I'm using this for every single class, but given is gone. We're not using that. The next thing says, so E is the midpoint of DF. DE equals EF. If I look at my picture, they're saying DE equals EF. Out of these options, which one would make sense to write that? Nope, not segment addition because I'm not adding, not transitive property. Nope, not simplify. Definition of midpoint, because if it's a midpoint, then I know that they're equal because the midpoint, so you're connecting the previous step to the next step. So we talked about midpoint, they're equal to each other. How do I know that? Because of definition of midpoint. From step 2 to step 3, it says DE plus CE equals DE plus EF. Notice that what changed from here to here is they're adding this piece on both sides. So that's addition property because they're adding the same thing to both sides. And then from step 3 to step 4, it goes 2DE equals DE plus DF. What did they do? They simplified because they combined like terms here. If you combine DE and DE, that makes 2DE. So that's simplify. Then it tells me DE, if I look at my picture, DE plus EF equals DF. segment addition, because you're taking piece plus piece equals whole thing. Anytime it's piece plus piece equals whole, that's segment addition postulate or angle addition postulate, whatever you're talking about. Seg addition postulate. And then obviously the last one's gonna be what? Transitive. And I'll show you why it's transitive. Because transitive is important. That's the one that's on the test. That's it. On your next test, not like the one on Friday, but like next week, there's only one proof. And then everything else is like those weird rearranging sentences. But the one proof has transitive property involved. The reason why this is transitive property is you're using like common sense because it's the last one. But the reason why is because they are taking these two things. They both share this part, the DE plus EF. I'm crossing that out. I'm crossing out DE plus EF and I'm combining what's left. This piece and this piece are equal to each other because I'm taking out what they share, like removing the middleman. We don't need him. He's useless. Okay. So let's go to problem two. Problem two, here's your options. Take a second. This one only has 4 options. See if you can figure it out. Step 1's always going to be given. So you have 3 to try to rearrange. Like my papers don't feel like, my papers feel sloppy. Yeah, like they feel like, I don't know, maybe it's me. Maybe I'm like. Right. Mm-hmm. Yes.
How about?
Okay, what's step 1? Given, okay. And then from step 1 to step 2, definition of congruence, because it goes from congruent symbols to equal signs. It goes from equal signs to congruence. That's the definition of congruence. Because if I know it's congruent, technically, like randomly they'll do that, but then given won't be like an option. Which is like, it's always given like the first step, but like unless given's not an option, then like they just kind of go into it, which is silly. 3 says KL equals LM. Symmetric's not even an option. Transitive property. Okay, so let's talk about transitive property. Transitive property is important. So it tells me that they are equal, and then notice that they get rid of what they share. They're saying KL and LM are equal to each other because they're getting rid of what they have in common. They're getting rid of LN. If I know this is equal to this and this is also equal to this, I can get rid of what they share and just set those two things equal to each other. The last thing says L is the midpoint of KM. So that would be definition of midpoint because you're literally talking about midpoint. Okay. Number 3. Let's keep them. Try to fill in the first, see if you can fill in the first 3 steps. We'll check the first 3 steps together, and then we'll try to fill out the rest. Or try to fill out the rest. Try 1 through 3 first, because you don't want to do the whole thing wrong.
You know, who's like a fire line that
Yeah, we haven't had one.
we have a bathroom, I mean. You know, the Allen City. Pretty close.
We do that. I think we had one last month.
Yeah, we had it in 30 days. Yeah, I'm lying. What about September? Shut up.
We had a fire alarm on the first day of school.
It was like one of those.
I don't know. I never read the emails that they send out, to be honest, so I never know when anything's happening.
Yeah. Yeah, we fired.
What?
It's gonna be 5.
When I went to Pinellas Park High School, literally we would have fires. I swear to God, once a week, we'd be stuck outside for like 2 to 3 hours.
Oh.
Yeah,
You told me.
because there was always squirrels getting in the electrical system at Pinellas Park.
Girls?
Like the squirrels would get fried on the roof.
Morgan is like a lot of school.
Yeah, I don't understand what's going on at Pinellas Park. They probably fixed it by now, but back up. Okay, you're outside all the time. Back in my day.
That one day, oh my God.
That's one thing that never happened when I was in high school. We never lost like AC. Okay, what's the first step? Given. Okay, thank God. We're getting the hang of it, kind of. It's what you, okay. Definition of congruence, because you're going from congruence to equals, definition of congruence. Because if you know it's congruent, that means it's equal. Okay, definition of congruence. 3 says PQ plus QS equals PS. TQ plus QU equals TU. What is that? That's not substitution. It's segment, addition, postulate. Because if you look at your picture, it's taking small piece plus small piece equals the whole line. So now from here, see if you can figure out the rest. Cross off what you've used. You're not going to use it more than once. Okay. Does anybody think they know 4? Substitution, good, because if you look at this, it's kind of weird to look at, but like they're taking this piece and they're plugging it into here. So they're substituting it in. Substitution. What about 5? Substitution again. 6 says PS equals TU. Transitive property, because what it's doing is it's taking these 2 pieces and equaling them to each other, and it's getting rid of what they share. They share the TQ plus QS, share the TQ plus QS. So transitive. And then the last one is definition of congruence, because it goes from an equal sign to a congruency symbol. So we're gonna do one more kind of together, and then you'll have 2 to do. Okay. How do we feel? Do we feel like this is random? I can't really like not math. I don't feel like it's real. Let's do number 4, and then you have 2 left. So take a minute. 4 is kind of long. 4, where's my options for 4? Here's my options for 4. Now, when you look at your options for 4, what do you notice? There's 2 givens. They split up your given information, because if you look, they gave you a lot for given. It says K is the midpoint of JL, M is the midpoint of LN, comma, JK equals MN. So I'm looking for the first step. Look how they said K is the midpoint of JL, M is the midpoint of LN. So this first sentence is the first, so that's given. Where else? 3, because it says JK equals MN, that is also given. So take a second, see if you can fill out the rest. Because they split it up because there was so much given information. Does anybody think they know too?
Yeah.
Nope.
Definition of midpoint.
Definition of midpoint. You have to think, you're connecting step one to step two. Step one says K is the midpoint of JL. M is the midpoint of LN. They're telling me JK is congruent or equal to KL, and they're saying LM is congruent to MN. They're congruent to each other. So we're talking about midpoint. So how do I know that they're congruent or equal to each other? It's because of definition of midpoint. You're talking about midpoint. The next piece is given. I would still read it whenever you're doing a proof. It makes sense. It flows. So this is midpoint. We're saying they're equal. So then it says JK is also equal to MN. So now I know that these two are actually equal to each other. So that's because it's given. So then it says MN equals KL and LM equals MN. If you look at the previous statement, these are exactly the same. What's changing is this part. It is substitute because this front part is changing and replacing the JK. It's replacing it. So substitution. After I sub it in, transitive, because it's taking out that middleman. So it says they both have MN in common. I can take out MN and I'm setting these two equal to each other. So transitive. And then then it says KL and LM, which is symmetric, because if you notice, it just flip-flops it. So since it flips it, that's symmetric. And then definition of congruence, because it goes from an equal sign to the congruence. No, but is that how it's ending every single time? No, because if you look at the other ones, the number one ended up with transfer property, number two ended up with definition of midpoint, 3 and 4. I don't know. So you have two problems. I'm working on making a little thing online right now, so you can take a picture of it and like upload it. I'm gonna put the options up here if it's awkward for you to like look at your options. I'm gonna put them on the board. So here's your options for 5 and 6. If it's easier to look up here than to flip flop your papers, yes, just leave your phone. I'll freeze this here so that way you can use these. So you have 5 and 6, that's it. Those ones both only have one given, so given's gonna be the first step for each of them.